Hello everyone. Hi. I hope I am audible and visible. So welcome to this session. And in this session, we have one special guest, Mr. Mridul sir. So he is working in Vultr as a developer advocate. So in this session, he is going to talk about lot of things. And if you have any kind of query, you can directly ask in the chat box. Okay. So let us welcome Mridul sir in our session. So hello Mridul sir, hi, how are you?
Hi, Sam. Yeah, I'm good. All
Okay,
right.
okay, sir. So please introduce yourself, and we will move ahead, and the session will be in your hand.
All right. So, hi everyone. I am Radul Swaroop, a developer advocate here at Vultr. So, in today's session, we are talking about Vultr serverless inference, what is retrieval augmented generation, how you can build a chatbot using Vultr serverless inference, and we are going to be provisioning a Vultr server, trying out the serverless inference API, and let's dive into the session.
Okay, sir, over to you, and I will be here. If you face any kind of issue, you can directly ping me. Okay,
All right.
thank you,
Thank
sir.
you.
Thank you.
Yeah. So we'll begin the session with looking at the product page of the Vultr Serverless Inference, understand what are its basics, what are its use cases. So as you can see, using Vultr Serverless Inference, you can serve Gen AI models globally, like across 6 continents. Since Vultr has 32 global locations, we are present everywhere. And like in India, we have Mumbai, Delhi, Bangalore. So let's go ahead and dive into what is serverless inference. So serverless inference is basically Vultre's API, right? Which is backed by all the latest Gen AI models, all the latest Gen AI models hosted on latest GPUs by NVIDIA, AMD, and you can use the serverless inference to build chatbots, to provide AI ML experience in your products. And let's look at some features of serverless inference. In serverless inference, you can use any of the models provided by Vultr, and at Vultr we provide models like Zephyr, Llama, or you can try to bring your own LLM, right? An LLM trained on your data set to use Vultr serverless inference. And Vultr serverless inference is self-optimizing, right? So it optimizes your performance in real time. So let's say if your application load increases as the traffic increases on the application, serverless inference automatically scales up to serve all your needs, all your requirements in real time. Inference at the edge inference at the edge meanings that since we are available across the globe, that means hardly there is in any area which you won't be able to use Vultr serverless inference. You can also use this product on our private clusters. So we do have GPU clusters where multiple GPUs are banded in together, and you can use those GPUs along with Vultr serverless inference. And we have RAG also. So RAG is retrieval augmented generation, where if a model doesn't have the context of your questions, right? So if you ask about a latest information which an LLM might not have, you can provide that information to LLM, right, and ask questions about it, and it will try to provide you personalized answers based on that questions, because we all know that LLMs are limited in their context. So they might not know something that is exclusive information to our product, to our company, and we are going to try turnkey RAG in the demonstration itself, right? And serverless inference is also OpenAI compatible, right? So it's easy to integrate AI models into common workloads. And yes, it only costs around $10 to start with Vultr serverless inference. So it comes at a very affordable pricing, right? Let's go ahead and look at Vultr community forums before we start with actual demonstration. So for this hackathon participants, we have created two discussions, right? where participants can come in, ask questions about their projects, about their queries related to Vultr, and Vultr team will try to answer all your queries and make sure that you go live with your project, you are able to submit your project into the hackathon, right? We also have another discussion, which is project ideas. So idea behind project ideas is that no matter if you didn't make it to phase 2, right? Project ideas is open for all. You can come here, you can post your project idea using Vultr products, right? Which incorporates Vultr products, whether you are a winner or not, right? We try to acknowledge every project idea because we know that each and every project idea is unique, right? So you can come in, post your project idea. And how do we make sure that you are rewarded for the project ideas? Because if we like the idea, right, we are providing our exclusive merchandise where you can come in, and where we will try to provide you with our exclusive merchandise, and you can post your project idea at any time at all, right? Make sure to incorporate Vultr products in your project idea, and that's how we'll be able to identify that if you are getting the merchandise or not, right? So as you can see, some people have posted their projects as well, right? So go ahead, post your project idea. You have a chance of winning Vultr merchandise, and we are looking forward to your project ideas. To every participant who is participating in the Geeks for Geeks Vultr Innovate Hackathon, right? We have provided an exclusive badge for you as well, right? So this badge showcases that you are a participant. You participated in Vultr Cloud Innovate Hackathon. You contributed with your ideas and projects, and this is helpful if you want to showcase your profile. And in the community, you can connect your LinkedIn accounts, GitHub accounts, right? For every participant in the phase 2 who have qualified for the phase 2, we have already sent you the Vultr community credentials on your emails. So make sure to check out the email, log in into your account, post your queries, post your project ideas, and we'll make sure to address those concerns. Now let's jump onto the agenda of this session, that is how to use Vultr serverless inference, right? So Vultr serverless inference, today we are going to combine it with retrieval augmented generation, right? Retrieval augmented generation, as the name suggests, it's about retrieval and generation, right? So here's a graphic. I'm going to explain you how this works. So let's say you have a personalized document, right? The information which is exclusive to you, right? Not that is not public information, right? So you can post that information to the model, right? And the model will try to create embeddings of it, right? Embeddings are mathematical representation of the text. Embeddings is the way how any LLM works, right? They understand our words through embeddings because they convert those words into mathematical representation, and they try to find similar patterns of those mathematical representations in their own database, right? So any information which you give is gone through an embeddings model, right? Then it has to be stored somewhere, right? So the model knows where is this information available. The user has asked a question about it, so where can I find this information, right? So as we have normal databases like MySQL, Postgres, right? For embeddings, we have databases which are known as vector stores, right? So in these vector stores, embeddings are stored, right? And we are also going to be using vector store in our demonstration in the next steps. So make sure to stay tuned, right? So when you feed a document to an embeddings model, it goes to a vector store, and then when you ask a query about that specific information, as if like what is Vultr serverless inference, when is Geeks for Geeks Vultr Innovate Hackathon, The LLM goes back to the vector store, retrieves the information, that specific information, and tries to answer your question in a more, concise and a more accurate manner. Now let's go through this document. The relevance of this document is the demonstration we are going to do in this session, right? I am going to be using all the commands which are given in this document. So whenever you are making these projects, you can also use these documents, try out the commands, and you will be able to, use Vultr Serverless Inference with retrieval augmented generation. So let's go ahead. So the first step is to create a vector store collection. In a vector store, we make a special place which we can name ourselves, right? A vector store, we make a special place in which we are going to store a specific information. Then we send an API request to get the collection ID. Whenever, let's say, for example, whenever we go to a restaurant, whenever we go to an hotel, we are provided a hotel key, right, which is uniquely identifiable. So that's how our vector store collection will be identifiable in the with the LLM, right? In the vector store, we are going to give some content which is exclusive to us. That can be any content, be it, if you want your bank statements to be analyzed, if you want, if you want to predict, let's say, anything, right, providing weather reports, which is the data only you have, and you want LLMs to answer these questions, right? So you can provide that data, providing the collection ID. Whenever we go to a restaurant, the hostess tells us, this is the table number you have to sit. So we have to give this collection ID so that the models know into which collection we have to store this data, right? As you can see, content is the text that will be converted into embeddings. Repeating myself here, embeddings are mathematical representations of the text, right? So they will not be stored as text, they will be stored as mathematical representations, right? And the descriptions is labeling them, how what is the data itself, right? And then we are going to view the collection item as to making sure that that collection item is present in the vector store. And then we'll try to send a prompt to the LLM, right, to answer a question about the information we provided. In this demonstration, I'm going to be providing information about this hackathon itself. Now, because this hackathon is happening as of now, right? So the LLMs don't have the information of what is the date of the hackathon, what is the theme of the hackathon, right? So I'm going to be providing that information, which the model will save into a database. And when I ask a question about it, the model will try to give us a concise answer based on that information. So, in conclusion, like you can use Vultr serverless inference for RAG or for normal prompting, doing a normal chat with the model. Now, we'll go to the Vultr customer portal, right? We'll provision a server. We will provision Vultr serverless inference, and we'll try to use Vultr serverless inference with retrieval augmented generation. So let's go ahead to the customer portal. So here, as you can see, I am on the deployment screen. Here, I am going to be deploying a server.
Uh,
Uh,
Hello, sir. Sorry to
yes,
interrupt you, sir. Before we move ahead, we have some comments. So
yes.
let me read these, and you can answer them, and we will move ahead. Okay. So the first comment is: should the content be a string, or can it be a document like PDF?
All right. So great question. As of now, we provide the support for strings, right, in the Vultr serverless inference. If you want to use RAG, if you are building a chatbot with an interface, let's say, you can provide a PDF that will be converted into a text on the background, right? But that's up to the developer. when you are sending an API request, because API request only supports string format. So when you are hard coding something, you have to provide it in a string format.
Okay. Okay. So thank you, sir. Thank you. And you can proceed.
All right. So on the deployment page, Vultr has many options to choose from the server types. We have optimized cloud compute, we have cloud compute, cloud GPU, and bare metal. The great thing about Vultr serverless inference that you don't need to have a GPU to use Vultr serverless inference. That means eliminating the GPU cost, you can still utilize the AI ML capacity in your projects. So here I'm going to be choosing optimized cloud compute, and about in the 32 locations you have, like, it is preferable that you choose a location near to you. So I'm going to be choosing Delhi NCR. In the image section, Vultr provides lots of OS choices. So here I'm going to be selecting Ubuntu with the latest version. So we also support the latest version for Ubuntu. So that's 2410. Let's go ahead and select a size. So I'm going to be needing 8 GBs with two virtual server CPUs. In additional features, you can select features to enforce security in your server, like to protect them from malpractices. You can, if you are in a team, you can select feature according to that team, whether it should be a limited user login. If you are using a virtual private network, so you can also select VPC, which is virtual private cloud, or VPC 2.0. Right, so here I have selected auto backups and IPv6. All right, so let's deploy the server. Always remember that deploying a server can take anywhere between 2 to 5 minutes. Meanwhile, when our server is deploying, let's go ahead and provision Vultr serverless inference. So in the product section, when you go to serverless, you will find inference. Here, as you can see, I'll add an inference service. I'll provide it a label, and I acknowledge the charges, that is $10 base monthly. As I am aware, all the participants which have qualified for the phase 2, we have provided you credits, so you will be able to provision Vultr serverless inference. Let's click add serverless inference. As you can see, our serverless inference is ready to use. So Vultr has also provided UI windows to test serverless inference. So if you go to the prompt window, you can type in a prompt. Let's say we ask about what is Vultr, right? If you want the prompt to be answered by a particular model, so we have choices for that as well. Mistral, Llama 2, Bloom. For me, I will be going to selecting Zephyr, right? You can also select max tokens. Max token is the number of tokens which the model can use to answer the question. So if you increase the number of max tokens, you will get a longer answer, right? So I'll send the prompt. Let's see what we get. So right now the model is trying to understand, and here, as you can see, the model gave us the answer in a few seconds. You can also rate this response, and prompting is, people often get confused between what is chat and what is prompting. So in a prompt, you can only send one message at a time, right? For chat, it is like chatting when you are sending multiple messages together, right? So we'll also try out chat. In the chat also, you can select multiple models. You can also select max tokens. So I'll try to send a chat message. What is Vultr? Right now the chat is loading. You can also view the history. So as we are trying it the first time, all over the message we sent, right, they will be stored into the history. This history is used by the model to understand what has happened in the chat before, right, before you have asked this question, right? So as you can see, the model answered the question and it stored our message into a history. Now whenever we send a next message, it will try to understand what was the message previous to the message we sent right now. right? You can also view text to speech. So text to speech is a cool feature where you can, type in Vultr is a cloud company, let's say, right? And you can tell the model to convert this into a audio, automatic audio. For the audio, you can select in amongst two models, that is Bark and Bark Small, and you can select various voice types, right? So female, male, and they are all English speaking voices, right? So if I click on prompt, right, right now the model is trying to understand what is the text. It is generating embeddings, and then it will use a text to audio model, which is Bark, and generate the audio, right? So if I click allow, our audio is downloaded. Now if I have to play this audio, right, you can listen to this audio, and you can use this functionality as well in your models, right, in your projects, as to, to provide social media solutions where you are doing voiceovers, where someone doesn't have to use an actual person to convert a text into a voice. You can just come here, type in your text, and convert it into a voiceover, right? Next, we have embeddings. So here you will see as to what kind of mathematical representations I was talking about, right? So if you type in Vultr is a cloud company, our embeddings model Zephyr 7B will try to convert this text into embeddings. Embeddings, as I have tell, that these are mathematical representations which you can understand, right? Which models can understand. So you will see right now as to what is the format of embeddings. So I'll here click generate, right? So this is an embedding. Here, as you can see, these are numbers. Some are in negative, some are in positive. These numbers are used by large language models to understand as to what is this word, like what is the meaning of this word. It will try to find out any word similar to this as well. So this is how, whenever we give a text, it will be converted into these embeddings, right? It will be stored in a vector store, and then the model will come back, extract these embeddings, look into its own database, and try out to find a word which is similar to the context we have provided, right? So as we have tested Vultr Serverless Inference, which is available on the customer portal, let's try and test Vultr Serverless API, right, in a Vultr server. So I believe the server is ready now. All right. So on the customer portal, we have the IP address and the password. So I'll go ahead in my terminal.
Okay, sir, can we take one more question before we move
Yes.
ahead? Someone asked, like, can we create a chatbot that accepts images from the user and extract the text from it using this?
All right. So right now we have text to speech functionality, text to text functionality. But if you want to use images, right, you can use your own local model or a model trained by you to understand the image, right? And you can use Vultr Serverless Inference as an extra layer to answer the questions, right? You don't have direct support of text to image as of now, right, or image to text as of now, but yes, you can put in an extra additional layer that understands images, converts it into text, right, converts it into embeddings, and use Vultr Serverless Inference to, trigger a prompt or to have a chat.
Okay, okay. Thank you, sir. Thank you.
All right, so let's log into our server here. So as you can see, right now I'm inside the server, and here we will try to incorporate Vultr Serverless Inference. All the commands which I am going to be running in this demonstration, as I have mentioned, is available in this document. on Vultr Docs website, right? So these are the same commands which I'm going to be running right now. So the first step for us is to provide an API key, right? That API key will be used to identify whether the service you are trying to use is belonging to your account itself. So in Vultr, right, we provide a special API key for Vultr serverless inference, right? So I have this provision. Here I'm going to be copying my API key, right? You have to use this API key to use Vultr serverless inference. And I will export this so that I don't have to type in my API key again and again, right? So I've exported my API key. Next step is to create a collection in the vector store. So let's go ahead and send a API request, right? So here, as you can see, we have a field of collection name. So we have to provide a collection name. Let's say GFG Hackathon, right? This collection will be created in the vector store provided by Vultr. So you don't have to have your own vector store. You don't have to have your own database. You don't have to have, let's say, a model which converts your text into embeddings, right? And let's send the API request. Here, as you can see, I'm using curl. You can use this API endpoint into your applications directly. So your application, your UI, your front end will communicate directly using this API request as a backend to communicate with the models, right? So as you can see, our collection is created. It has an ID of GFG Hackathon and the name GFG Hackathon. So I'm going to be sending. Now the next step is to retrieve the ID of this collection API key. Right now we have the ID, but let's say if you have multiple collections, right? If you are having multiple collections items in many different databases, you can send a API request to get those IDs, to get a specific ID which you want to use. So let's send a get request and retrieve all the IDs here. Because we created only one collection item, we got only one ID, right? This is GFG Hackathon. This is the ID which we are going to use to identify that, you know, which collection item this data will be stored in. So the next step is to actually give the data, right, which is going to be converted into embeddings, going to be stored into the vector store. And how will the vector store know where to store this? By using this collection ID, right? So I'm providing the API request. Here, as you can see in the content, I have provided that Vultr Hackathon with GFGs happening on August 22, right? And we are providing technical writing role to the winners as well, right? And the finale is on November 19. This is the information which the LLMs won't have as of now. So they won't be answer, so they won't be able to answer any questions, right, regarding this. But now when I'm giving it the required context, it will be able to answer this when I ask a question about it in the next step. So before you send the API request, right, you have to provide your collection ID so the vector store knows where to store this data, right? So my collection ID is GFG Hackathon. So the vector store now knows that this is the data which has to be stored in a collection item named GFG Hackathon. This helps because the information regarding this, right, the GFG Hackathon information is now going to be stored in a collection named GFG Hackathon. So let's send the request. As you can see, the content has been sent to the model, right? It has been converted into embeddings. It is happening in just few seconds. So the latency of the request going and the data coming in is very, very low in nanoseconds. We have been provided with the collection item ID. So we have now three things: a vector store, a collection, and a collection item, right? So we have been provided with this collection item. We have been provided with the date as to when was this collection item was created. We have some data as well as to like what were the total count of tokens that were stored, right? So 67 tokens means this paragraph was divided into 67 chunks to get stored into the vector database. Now the next step for us is to test whether is it working or not, right? As of now, what we are assuming that when we have provided this information to the model, which it didn't have before we gave it, right? So now it should be able to tell us actually when is GFG hackathon happening, right? So I'm going to be sending this request here. As you can see, we can adjust the request as well, which is top P, temperature. So explaining some on the parameters, these are known as the model parameters. As to do you want to control the quality of response? So temperature is about randomness of a prompt, right? If I decrease the temperature, the prompt, the language which will be used by the model to give the answer will be more random, less certain, right? It will use some of its own information to answer the question, right? And max tokens, as I have already explained, max tokens is when you give when teacher used to tell us, you have to write an essay in 100 words, right? So here we are trying to tell the model that whatever question we ask, you have to limit it to 512 tokens, right? So it will not never exceed the number of tokens used in the response, uh, uh, like beyond 512, right? So here I'm going to be asking it the question: when is the GFG hackathon finale, right? As of now, only we know that data and we have stored that into a vector store, right? Here is the model we are using, which is Llama 2 7-bit chat. It is quantized up to 5-bit, but that's a more advanced concept. Llama 2 is one of the open source models provided by Meta. It is one of the latest models which is having the capability to answer up to any question we want. We also have to provide the collection ID. So if you remember, our collection ID is GFG Hackathon. And let's send this request. Let's see if the model is able to answer our question, right? So we have received the response. As you can see, before I completed my sentence, the model is able to answer the question, right? So coming back to the latency part of it, there is literally nanoseconds of latency. The model is saying that based on the information provided in the context, the Vultr Hackathon Grand Finale is scheduled to take place on November 19, 2024. We have been provided with some data itself. Prompt tokens is 150, completed tokens is 36. That means this answer is divided into 36 chunks to answer our question, right? If I increase the max token count, the model will try to answer it in a more elaborate way. And we can also control the randomness by manipulating the temperature. So the max value of our temperature is up to 1, and the lowest you can go is up to 0. This is how you can use Vultr Serverless Inference API endpoints to build your own UI, to build your own front end application, plug Vultr Serverless API into the backend, and build a chatbot. As of now, chatbots are everywhere, right? Every platform, every product which is around us is based on a chatbot. Even support helplines are now first going to chatbots. This is why building a chatbot, knowing how LLMs work has become quite essential to build projects, to build innovative ideas. So let's go ahead and look at some use cases as well, right? So I understand that the theme of the hackathon is also about financial services, is also about healthcare and life sciences, media and entertainment, retail. These are the use cases of vulture serverless inference as well, right? So you can provide context, you can do some prompt engineering to build telecommunications applications as well, right? So if you want to analyze real time network traffic of a telecommunications provider, you can do so with an LLM support, so that it gives you valid answers to build a telecommunications app. For retail, you can build a customer support app as well, right? Where customers are asking as to, these are my preferences, what kind of a product would I want, right? You can obviously store customers preferences, right, upon their consent, and provide suggestions based on their preferences using retrieval augmented generation. In financial services, you can use these chatbots to detect fraud automatically, right? You can also do real time risk assessment when you are providing a service for loans or insurance. And for healthcare and life sciences, at one point in time we have always used Google as to identify what are the symptoms of a disease, how this happens, right? So you can use a healthcare chatbot, you can build a healthcare chatbot, right? And you can provide personalized advices to the customers, to your users, and give them some advice which can help in their well-being. That is it. This is what is Vultr serverless inference, how it uses large language models. You can use it to build bots for converting text to audio, your own chatbot. And for starting up, it only costs $10. If you go to the portal, right, you can also view the usage as well. So as of now, as you can see, I sent a request, it gave me a request. So we also show real time usage of your tokens, right? And you can track your usage here as well. That is it. This is how vulture surveillance inference works. And you can integrate these in your chatbots. And yeah, like, thank you everyone for joining in. And yes, I would be happy to answer some questions.
Okay, sir. So, thank you so much for this informative video. Let us move ahead and see some comments. Someone asked, does max tokens from model parameter represent uh, the tokens used for charging price for serverless instance?
Yeah, so that's actually a really nice question, right? We have to all monitor our expenses, our usage. So when you are paying $10, you will be provided with the base amount of tokens. You can view that in the documentation as well, or when you are provisioning the serverless inference. So when you are adding the serverless inference, you can see in the acknowledgement charges, it is mentioned that $10 base monthly cost charge upfront, which includes around 50 million monthly chat tokens, right? So you will be able to use 50 million chat tokens, right? And any additional tokens beyond that is charged at like 2 cents per thousand token, right? So this is the information to answer the question.
Okay, thank you, sir. And the next question is, someone asked like, it means something we need to ask first. We need to store the data in the vector store only, then it will be able to answer.
Yeah. So if there is an information which is exclusive to you, right? Which is not available on any public forum, right? Anywhere on the Google, and you want any questions to be answered about that. So you have to store that information in the vector store first, and then you will be able to ask questions from LLM about that information.
Okay, okay, thank you, sir. Anyone else has any question? You can drop it in the chat box and then we will bind up the session. Okay. Please
I-
ask your
yeah.
question in the chat
I would
box.
like to reiterate myself here as well in the community. You can also post any questions in the community as well. The Vulture team is active 24/7 to answer any queries when you are facing using Vulture Serverless Inference or any of the Vulture products while building your projects.
Okay. I hope this session was very helpful for everyone. And thank you, sir. Thank you so much for joining this session. And yeah, we can bind up. And
All right.
yeah, for
Thank you,
further
Sayam.
queries, you guys can ask in your Telegram group as well. Someone asked, can you show how we can connect our own LLM with the one provided on Vulture platform?
Yeah. So when you want to connect your own LLM, right, run these APIs on your local system. You can plug in your own LLM, which you are running in your own local system. Instead of prompting the model on the Vulture platform, you can prompt the model in your local LLM. Make sure if you are using the RAG functionality, right, your model is able to create embeddings from that from that API request, and you have a vector store to store all these embeddings.
Okay, sir. Okay, so that's all from our side. If you still have any kind of queries and question, you can directly ask in the Telegram group. Okay. So thank you so much, sir. Thank you for joining, and it was a great session. So we can bind
Thank
up.
you.
Thank you, guys.
Yeah, thank you,
Thank you.
Sayam, for having me. I hope you guys understood what is also serverless inference, how you can use it to build your own projects, and make sure to post your project ideas. You always stand a chance of winning the Vulture merchandise, even if you have not qualified for the phase two, or even if you do not win. Thanks
Okay.
a lot.
Thank you, sir. Thank you. So bye, everyone. Bye. We are binding up the session.
Thank you.
Thank you.